Corey, I just want to kick this off. You're CTO over at Rokt. You were VP of engineering at Datadog. Not an easy job. You led SRE, you led multi-cloud, everything under the sun from one of the fastest growing companies we've seen in this modern era. Prior to that, you led the Hillary Clinton campaign. All of that after your work at Netflix, where you wrote Chaos Kong and Chaos Gorilla. So really what I'd like to understand, I think that a lot of people that are attending this and watching the video want to understand is, what's your experience with chaos? What was young Corey 10 years ago? You go over to Netflix. How did that start, and how have you seen it evolve into building the career that you have today?
Thanks, Andrew. Appreciate it. Yeah, so my introduction to chaos engineering was kind of from a sideways angle. And Netflix was already doing Chaos Monkey at the time, which really kind of helped them adopt cloud as they were moving into AWS at the time. This is like very early EC2. There was like very little service spread of AWS at the time, very, very early days. And Amazon had come to Netflix and basically said, it was like maybe my first month there, and said, hey, we want you to leave an AZ. And at the time, like, that was like, no one knew how to do that. And no one really understood, like, we had so many databases and stateful services and everything under the sun kind of running, what was early streaming for Netflix with about 20, 25 million customers at the time. And, really we were like, we don't know what the hell we're going to do. I was like, all right, I got this, whatever. And like young baby me was like, sure, I can figure this out. And so realistically, Chaos Gorilla, eventually ended up being a region evacuation test, but in reality, it stemmed from the need of Amazon being like, get the fuck out. Pardon my language. And so it was an interesting path into it. None of us really knew what was going to happen when we ran it. Thankfully, many of the services and a lot of the thought process around chaos engineering and a lot of the learnings from Monkey really kind of enabled us to make this move. At the end of the day, this was like a big shift of traffic. It was a balancing of instances. At the time, we were 90% of a couple AZs in AWS at the time. Like, we're pretty huge, and AWS is much smaller than it is today. And so as we kind of ran that exercise and watched traffic shift, surprisingly, when we hit the button, it just worked. It's one of those things that's, in terms of early days of chaos engineering, like, there was very little, way for us to actually test it other than just to hit go and see what happened in prod. Thankfully, everything went very smoothly. We were able to kind of reshift all the traffic. We, ultimately, again, thought about how do we balance traffic in real time, so that we're not burning too much cache, but at the same time, protecting the customer experience. And then, eventually that kind of spurred into about 6 months later, we had the big, and for those who were on AWS at the time, they'll remember this, it was the big Christmas outage, where ELBs basically globally went kaput. And so, Netflix kind of sat down, after feeling a lot of pain on Christmas Day. I remember being on a phone call at work for about 16 hours straight. Netflix was like, all right, we're going to go multi-region. We're going to figure this out. We're going to, be a global organization. We're not going to be tied to any individual region at the time. And so after about 6 or 8 months, I want to say, and this was all hands on deck, Netflix really doubled down, said, hey, we're going to figure this out. A lot of time, energy, and effort thinking about how do you do global data stores? How do you kind of do global replication? How do you do global caching? And again, at the time, we're probably about 35% of the internet traffic, which is like not an insignificant amount. And at the time, we're probably about 50% of EC2 in US East. And so, really trying to figure out how do you kind of shift that amount of load? How do you shift that amount of compute across the globe in real time? How do you kind of balance that? And so, the early work of Chaos Gorilla really kind of evolved into what became Kong, which we now, when I was leaving, we called it Flow, because so much of that is not just how do you kind of divide traffic up globally and think about, how do you shift traffic from east to west or to, globally from, Europe to US or to America, but generally like even subdividing the country by GeoDNS, along with then once as you're shifting traffic and as you're thinking about portions of traffic, how do you make sure that systems are safe? How do you offload traffic? How do you black hole traffic so you don't DDoS yourself when you go, hey, we're going to shift all this DNS over? And so, pretty significant lift at the time when we ran Kong the first time. Honestly, I was terrified. Uh, Early days of testing Kong, we actually caused an AWS outage on their APIs because of the way that they fan out. AWS was not thrilled with me. Uh, and then, when we actually ran it, we ended up having, I think early days, it was about 40 minutes of degraded service, just to shift, 35, 50,000 nodes and trying to figure out how do you, manage traffic in that. We ended up really getting them, at the end of the day, where it's really just a question of like, how much money do you want to burn in these exercises? And so we ended up, ultimately running a little bit cold at the time, so that we could handle that traffic shift in real time and ultimately getting that window down to what I want to say right now, last I heard, they're like in the 5-6 minute range where they can shift entire regions from one to the other. The other big challenge here is, we had started the EU region and we just left GeoDNS to like handle it. And so like every EU customer just landed in the EU and like that's how we did data locality through GeoDNS. And so like trying to unwind that and figure out how to bring that region back in and then shift traffic between the three regions as we went to west to east to EU. And then ultimately, they've obviously expanded since then. It's a lot of work. And again, like I was a baby at the time, just kind of like trying to figure this out. EC2, AWS was so early stages. This is still 2012, right? None of the services that we have today exist. None of the niceties of AWS and like global replication that they'll do existed. And so we were just kind of like exploring the world at the time. It was kind of wild.
Yeah, I can imagine. I don't want that job.
uh, I was like too dumb at the time to realize how stressful it was. And now in retrospect, I'm like, oh my God, like I don't know if I could do that job now.
Yeah.
It's one of those things you really, and again, at the time, cloud was so early that you're like, oh, it's just it's just an API. What could go wrong? Turns out like a lot.
Yeah, that's one of the things I like most is you talked a lot about the tooling, a lot about the process and extent. One of the things I like most about chatting with you and chatting to your teams is you build these high performing engineering orgs. You'll help restructure to meet modern needs and scaling needs. And you do so, you have the initiative to do so, and you do so without really alienating a lot of people. Like when you go to a new company, I'll check out LinkedIn. Within the next month, I'll see 10 more people from another company you've worked with jumping over with you. So how do you build out like this high performance culture while also keeping the culture you want just overall?
Yeah, it's an interesting ask. I think that, listen, I obviously from company to company doing what we do and thinking about this level of traffic and this level of load and just the challenges of kind of building high performing, high scale teams, it really does require a high bar. That said, I think at the end of the day, you have to trust the people you work with, right? It is really a matter of if there isn't that underlying trust, if there isn't that underlying like just autonomy, choose the right thing, do what you think is right, trust you to do it, it all kind of falls apart. And so in my experience, I think, ultimately building these teams, especially at hyperscale businesses that are just moving a mile a minute like Rokt, it is, one of these things that if you're not ultra protective of culture and you're ultra protective of the team, it all starts to fall apart very quickly. And then even you see it in both teams, but then also that perpetrates into how the infrastructure runs, and that perpetrates into how everything runs. You see it in the way people respond to incidents. You see it in the way people respond to just challenges. Ultimately, you really do have to keep the bar high and trust that people are going to do the right thing. And if you're not building that circle of trust, that underlying layer of trust, I think that you're kind of doomed. You know, if every other business I know that is growing a mile a minute, and every other, leader that I know at these businesses, if you're not making those decisions, ultimately you're in for a world of pain. And so, I've had the really wonderful and fortunate experience to be able to work with some pretty incredible people, both at Netflix and the campaign, at Datadog, and now at Rokt. And one of those things is that trust travels, right? It's one of those things I came to Rokt and I was like, hey, let's do it again. We're ultra high scale. We got to just figure this out, move a mile a minute, ultra low latency, a ton of challenges. Come on in. And so, that's something that I think, everyone should be thinking about, like the people you work with, right? Life is short. And if you're not having a good time and if you're not making it fun, I'm like, why are you doing it?
Yeah, exactly. And that's one of the things I like most about that. And you kind of mentioned it earlier. You don't know if you could go back and do the work that you did beforehand. One of the key things is I think we've all been in a situation maybe where we had a manager who we didn't know believed in us. How do you react in a high stress situation like that? Whereas if you have kind of a blameless mentality where you learn from the incidents, you learn from failures, building that culture out, I just feel is just absolutely critical.
Listen, I if you have a manager that doesn't trust you, find a new job. That's ultimately, I think, necessary. They're really, you need that, especially when you think about incidents, you think about chaos and kind of these types of, honestly, without the trust of Netflix and the team, like I caused some significant outages at Netflix. Like honestly, like front page of the news outages, but my manager at the time was like, you got this, just go. And you're like, honestly, I didn't have it, but we just figured it out as we were going. This was so early days. And I think that has kind of stayed with me. I think, that level of, you really, I don't care how much experience you have. If I'm asking you to fix something, it's same team, right? Or we're all one team. I'll roll up my sleeves. I will get in the weeds with you. We'll figure it out together. At the end of the day, you're not alone, right? And I think that that's super important for any team in thinking about, not only outages, but like these type of exercises. It's really takes a team effort. It takes a village. Uh, One of the best people I ever worked with at Netflix. Honestly, I was terrified of doing these exercises on our data stores at the time because like Cassandra is a nightmare to operate, especially back in 2012. Like it was not that advanced at the time. And so the Cassandra team was like, absolutely fucking do not touch us, like go the hell away. And I was like, no, we're gonna do it. And like this engineer, you know, former Yahoo was just so kick-ass. And he was like, we're doing it. And he's like, I'm adding you to the list. Or you're like, you're not on the exceptions. It was like, okay, here we go. If he hadn't, had my back like that, I probably wouldn't have been, able to kind of push it. But it made us better as a business. And so I think, really relying on the people around you, I don't care how much experience it has, up or down. Like I think to be successful at these types of things and to be successful at these type of businesses, it's necessary. Like there's no other way to do it.
Yeah, yeah, and obviously chaos engineering isn't for every team. You don't want to if your SLA is 2 nines, you're probably going to be okay. But I'm sure that you probably had stints, at your different companies you've worked where you've seen that teams really do need to get started. Like there's a lot of dependencies that are pretty critical, relying on them. There's been issues that could easily be remediated. Can you tell me a little bit about your process of identifying the teams that need to get started, that need to make these improvements, and how you kind of sell that to them internally?
Yeah, chaos engineering kind of went through this weird phase, especially like maybe 5, 6 years ago. We did all this work. We were very vocal about it. A lot of people, uh, you know, really went out there and said, "Oh, we're going to do chaos engineering." It's easy to throw a grenade at a service. It's super easy to blow something up. Fixing something is hard. And so, there was this like weird phase there where like everyone's like, oh yeah, Chaos Monkey, we just kill stuff. And it's just like that's not always that helpful. And it really depends on the business. And I think everyone who like wants to be thinking about these types of tools or thinks they need these types of tools really needs to kind of assess where they are in their journey. Um, I would argue that there's much more benefit really focusing on resiliency, reliability, and uptime than there is about, worrying about the worst case scenarios, especially nowadays as cloud has evolved, as the underlying tooling has evolved. A lot of what we've done in chaos engineering over the years has kind of evolved and moved into the space of like Kubernetes and a lot of the stuff that you see in the CNCF right now. Like there's this underpinning of these learnings that everyone's now, gaining from. And so like these types of exercise and testing is less and less important. And it's more thinking about how are you structuring your infrastructure for resiliency. Um, I encourage every organization to be thinking about worst case scenario. Obviously, it does happen even today. We see these massive global outages on Azure and even GCP, and then sometimes even AWS. Obviously, everyone's gotten a lot better right now, but it is there's still that underpinning. And so, ultimately what we've done at Rokt, for example, is, really kind of built with multi-region in mind. But we've been able to do that not only because of the learnings that AWS has learned and given us from a global resiliency perspective, but because we're able to move on to Kubernetes and kind of take advantage of how we think about traffic and global traffic. And then a lot of the CDNs that are out there are thinking about this as well. And so it's a little bit easier. Obviously, this starts to become problematic when you're a Google, when you're a Netflix, and you're like, oh, we're X% of internet traffic, right? When you're at like double digits of internet traffic, moving stuff around is hard. But ultimately, there are ways to kind of tackle that as well. For smaller organizations, I encourage folks to do game days. I encourage folks to think about what would happen and especially thinking about like at a service level, some of the stuff that some of the organizations really did around like application level chaos engineering, I thought was pretty interesting and still is. But at the same time, a lot of the frameworks we're now using and building on top of kind of think about this and have stitchers of like underpinnings that really kind of help mitigate a lot of the challenges there. And so it's been interesting to watch the entire industry kind of evolve over the last 10 years.
Yeah, I can imagine, for sure. We've got a question from the audience, and they're curious about your perspective on chaos engineering for machine learning ops.
One, I think ML ops is moving a mile a minute. And so, it introduces its own level of chaos. I'm not really sure you have to test it because things like Qflow, Tensor, PyTorch, like these things are not the most stable of platforms at the moment. It has been interesting to watch ML ops kind of evolve over the last couple of years, and people be thinking about these platforms. I cannot wait until the clouds get their shit together and like I don't have to think about this anymore. The fact that I have to staff an ML ops team is honestly kind of a nightmare. Like everyone's like, yeah, I guess we'll do that, but like no one really wants to because it's like just pure chaos, truly. And so I think for I've never seen an organization not just kind of blow up once a week anyway from running ML ops just in their own way. So I haven't seen anyone doing chaos engineering in the ML ops space. I don't feel a need to do it. At the same time, a lot of what you've seen in the ML space isn't necessarily real time. There's some stuff happening in TensorFlow and real time serving. We do a lot of real time serving as well. That part of the infrastructure is usually pretty stable. Model building, models blowing up, stale data, all of that like doesn't really impact organizations all that much right now. I'd be interested in hearing other use cases around this though, because I do. This is something that we thankfully avoid at Rokt, even though we are heavy into ML. A lot of worst case scenarios like, oh, like the data's 2 hours old, right? It's a little bit stale, and we go and kick the entire cluster and like let it bring back up. We haven't really had any challenges outside of that. But again, would love to hear other stories.
Any other questions from anybody? Wait for it. All right. Now, Corey, I know that you have a hard stop. I heard you have other things to do as well. So I'm just curious. Is there anything that you'd like to, share with the audience in general? Some words of wisdom. I'm sure a lot of people kind of would look at your career trajectory and be like, "Whoa, that's pretty impressive."
Listen, I woke up one day and I was here. It's one of those things that like for me, I love I love this shit. I love it so much. Like I can't help myself. I'm an engineer through and through, and it's been really wonderful, having the opportunities that I've had to work with the people I've had, to learn from the people I've worked with. I encourage everyone to just, lean in, stop trying to impress everyone else and just do what you love. I really I can't stress that enough. Like I said, life is short, and if you're not having a good time and if you're not enjoying this, and you're not making a little bit of fun of it, like what else? Why are you doing it? It's one of those things that I really we make the world we want to live in, and don't let anyone tell you you're right or wrong. Just figure it out. Just go. Just move, and build some cool shit. And then open source it so we can all use it. Thanks.
Yeah, man. At the end of the day, you have to understand that you're going to make mistakes, and those are just opportunities to improve. And if you're judging your coworkers when they make mistakes, you're going to expect the same behavior back, and it just creates toxic natures.
Totally, man. Especially when you're thinking about chaos engineering, you're thinking about, just hyperscale, like shit happens. Get ready, buckle up. That's why we do this. It's preparing for the worst. It's understanding that like that's just life. So I encourage folks to just roll with the punches, figure it out as you go, and do your very best.
Hey man, we're really thankful for you, calling in today, sharing some of these words of wisdom, super, super relevant. I'm looking forward to seeing how many people engage with the video and we share it afterwards. And I'm also very thankful for everyone showing up today, and hope that you all found today's session, that this section of today's session very valuable.
Yeah, no, thank you very much, man. Appreciate it. You guys are doing great stuff over there.
Thanks, man. We appreciate it. Good luck.
Thank you.
Corey.
Yeah.
Great, thanks, Corey. All right, so we're gonna switch on over to the use case, and we've got Matt again, back to Matt and Andrew. Matt again was a former product owner and of disaster recovery and chaos engineering at Target. So Matt, let's turn it back over to you.
Yeah, thanks. I would like this to be interactive too. So the story I'm going to tell, like, it resonates with SRE personas, platform owners, developers, compliance analysts, folks, security. So like, if you're trying to build out a chaos engineering program and you're working with those personas and I'm not answering something for you, or if you want me to drill in, just like ask, interrupt. Andrew will be monitoring the chat too if you don't want to speak up, but I encourage you to unmute and ask questions. So the story I have here, so back in 2016, when I joined Target, I had just left working at a nuclear power plant for 13 years. So you can imagine the technology at a nuclear power plant is state of the art, right? Top, cutting edge using Kubernetes, not really, right? So when I walk into Target, I was on the IT disaster recovery team, and we had these plans. So I'm sharing this is just a random template on the internet, but this is what like a disaster recovery plan, in 2016 kind of looked like, right? 10, 12, 20 pages, right? That talks through high level outlines, the people, the call tree structure that you have to have when a disaster happens, right? Like hot sites, cold sites, the restoration process, scripts, like how many computers do you need to buy to whatnot, right? It's kind of painful. Now at the nuclear power plant, we had this stuff. At Target, there's still DR plans like this, right? But walking in, I was talking to a team, and I had their DR plan in hand, and I'm like, all right, let's walk through and update it. Let's kind of tabletop exercise and how we would go through this, because we're gonna, execute this plan here in a month, right? So as I was working with the engineer, they were like, well, we actually just revamped everything, and now we're on Kubernetes, and we don't need a plan anymore because Kubernetes is self-healing, and I just put it up there and we're good to go, right? So then I was literally like Googling Kubernetes in 2016 because it had kind of just come out. And again, I had no exposure to it, but little me, I was like, yeah, I know what that is, and I was kind of like understanding what it was, right? And then they're saying they're using Kafka and Cassandra and all these other technologies, right? And they're saying everything was self-healing and redundant, and we didn't need a DR plan, and we don't need to test things. So I was like, wow, I don't have a job anymore, like kind of like what Corey was saying, like a lot of things are protected against like these AZ and region failures, right? You can code to that. So what I ended up doing is I ended up going to the platform team, right, that was building this out. And I just said, hey, we have some application owners that say, your platform is self-healing and you don't need a DR plan and everything's good to go. And then they're like, whoa, hold the phone. We don't guarantee that, right? Like we still need a plan, right? We still need to test it. We still need to make sure that experience can protect the customer from any outages, right? So that began, then I was like, okay, great. I still have a job. I still can navigate through this, right? So, I took the platform team and the app team and working with my counterparts, right? We brought them together and just talked through, like SLAs, right? And like, what is that like recovery time objective if the system goes out? Like, what does data look like, right? Because interestingly enough, like recovery point objective, like with data too, right? Like people sometimes don't think about that. They just think, oh, my data is like in this Cassandra ring and it's going to always be there. And it probably will be, but there's SLAs around what that recovery looks like. So as we were navigating through this, we kept bringing in more teams, right, to kind of pull them together, because that ended up being our job, right? We're just pulling people together and getting people to talk, understanding, like, again, SLAs and how people interact with things. And it was just interesting, like pulling things together, right? And what ended up happening, like we ended up doing like old school DR stuff at first, right? Just with failover between data centers. But where this became was a cutting point for me was, okay, so like we updated the plan, we tested it, see you next year. Also, caveat, if your system changes drastically, like then we should update the plan and test it again, right? So we can't do just once a year testing. We should do it twice a year or something. And then, then it was like, well, there's this thing called, CI/CD, and, that's enabled us to push out code every day. So like we're creating new APIs and system changes like all the time. So our disaster recovery team right back in 2016 was like, wow, okay, things are changing frequently. So we can't just do test once a year. Like we need to figure out a way to do testing multiple times a year, right? And that's where like the whole chaos engineering thing came into play, right? So that back in 2016 and then 2017, we started researching, okay, what can we use to test when changes are happening so frequently in the environment, right? And what we ended up doing, I threw this, it's kind of like an architecture diagram, so just bear with me here, right? But in talking to one of the teams, right, like I'm just throwing out, they're using Kubernetes, it's an application. There's a messaging broker system, Kafka, and they have a Redis cache layer, and this API is being hit, and there's a Postgres database too in it, right? So we were mapping it out, and we were just talking through like, are there any single points of failure, right? Like, where are these caches? Are they in 2 data centers, multi-data centers, a single, right? This Postgres database, like how does it fail over to that? Like, how do we actually, like, when does the user actually hit that, right? And this message broker system, if that fails, what happens, right? Like if it's down for, 15 minutes, like what happens to that data? Does it queue up, right? So we mapped out, like we kind of took our old school DR thought processes, right? And we mapped out the architecture and we understood single points of failure as well as like specific failure modes. And then we leveraged like the chaos engineering experiments and principles that we started learning to like test each one. So we weren't doing full data center like failovers at that point. We were, like Corey was kind of saying before, we had to focus like on the architectural resilience, digging into all the connection points, right? So we would map out little experiments between each connection point, if you will, and like the flow of that user data, like where can it fail, right? And then if it fails, like why, right? If we inject latency, right, at what point will like some resilience mechanisms of the code, like with retry logic, right, and timeout settings and circuit breakers, when will that trigger, like going from one Redis instance to another, or if that's all down, when will it fall back to the Postgres database? So, 2017, 2018, again, still kind of focused on disaster recovery, but we were rebranding into a reliability resiliency team at this point, because we realized that we had to put mechanisms in place to test all the changes that were happening continuously, right? So as we drilled into this, right, we were like, sweet, this is going to be easy to do, and people are going to want to do it, right? And once we tell them why, right, why it's important, they'll sign up, right? What we realized though, right, is that it was like one more thing people had to do, right? And they had to already do security testing and load testing and all these things, right? So then our team was like, okay, we're gonna have to make this like fun, right? We're gonna kind of have to navigate through, marketing, if you will, going through the teams and leadership to understand like how to implement like a chaos engineering program. And where I'm going with this too is you'll see the pain that I'm talking about. It was good at the time, but there's ways around this now in, the year 2022 that we can speed through this journey. But some of the cute things we did was, we had like chaos engineering is all about the scientific method. So we'd pull up, like a little first grade homework sheet and just walk through, okay, this is how chaos experiments really work, right? You make a hypothesis based upon a question you're asking, then you test it, right? And then you record the results and draw a conclusion. So we literally did that like in a spreadsheet with this system, right? Where we injected latency until it triggered, a circuit breaker setting, and it fell back to like the Postgres database. And then we understood, okay, my user is still going to be able to, the API is still going to be able to call the data, although a little slower. And we'll get alerting in place to understand that, hey, the API is pulling from the database because the cache layers failed, right? So then we have validated our monitoring and paging and then the user experience. But it was a really slow way to move through a team, but powerful, right? And then we'd go team by team by team to implement this and prove it out and test it out. And this worked for a little bit, right? But then we started to have even more creative, right? So we came up, like, this is a fun idea I'm just throwing out here too, right? But like, think about this, like Cards Against Resiliency, just like Cards Against Humanity. So we had we were walking to leaders and teams and just throwing this out, because like everybody was always scared of the word chaos engineering. So like, then we would play this out, right? Like my CEO will blank if I tell her what we're doing, right? And if anybody in the chat wants to go off mute and like throw out a word in here, feel free. It's just kind of funny to kind of play through this, right?
Yeah, Matt, I'm just curious. You guys also kind of did a rebrand of the term chaos engineering at times with Netflix. How do you think this card might differ if it said reliability engineering or resilience engineering? It tends to take all the fun out of it. And is that a good thing for people trying to sell this in internally?
Yeah, I mean, ultimately, that's where I'm going to. Like our name, disaster recovery got rebranded into chaos engineering, and then we rebranded into resiliency engineering. Just for the folks we were working with, that resonated better, right? And after I left, the team went to like a Google Dirt term, which was kind of back to disaster recovery testing, because I think because of the pandemic, business continuity and disaster recovery became fun again, or important, I guess. But yeah, so the rebranding here too, right? Sometimes like the state of affairs at your company, you might not be able to like call it chaos engineering if somebody, is offended by that term. But at the end of the day, you're injecting a fault into your system, right? Every time you push code to production, you can be injecting an issue anyways. But then this bubbles up to, like outcomes that are themed against reliability, right? And if you don't have like KPIs or metrics that are measuring the reliability, then, that's another thing that you gotta kind of pay attention to. Yeah, there's a few more.
Another one. I want to see another one.
Yeah, so like another one here is, I run chaos engineer experience in, right? a lot of people think like production, non-production, or something funny too. Yeah, but anybody want to throw out a term in here to make this
Nightmares. What I love about like what you did at Matt, and you're another perfect example. Like I said, people follow Corey when he goes to different companies. They love working with and for Corey. Even though he really raises the bar, like he raises standards, he makes it fun though. He remembers the human, like we always say at Harness. And I followed you here. I've worked with you before. I love working with you because you do things like this. You remember the person, you look at how you're selling it in, and you take that into account as you're building out these programs. So I think it's just critical. You've gotta remember the social element and what you're trying to do and tailor accordingly.
Yeah, 100%. And the thing that with this too, right? We'll get about this. Like, it's not, you don't always have to automate everything, but like it'll help to automate chaos engineering, which I'll talk through. But you have to remember the human, right? And you have to kind of understand like what you're testing, what resilience mechanisms are recovering from that failure, and like how does it recover, right? If you forget about how all of that works and you don't like train the human and the engineer through that, or like the human dependencies in that learning, like if they don't know that they're reliant on this platform team or this database team, like you're not doing justice, right? You're not making like the culture better, right? Because it, again, right, like when you're at work, it's good. Like I enjoy working with Dave Nielsen, right? He's in community and he's like a dependency to my like marketing role and product, right? But if I forget about the human aspect of that, he's not just a piece of software or anything. So but yeah, anybody have questions as we walk through this, or okay?
Oh, Jenkins is back.
And then just like another last card, like my favorite tool to wreak havoc is, right? Like there's multiple ways to inject failure, like whether you're unplugging a power cord or using a tool to inject it, right? Or pushing to production. But it's just another fun way to kind of work through and talk to people just about, like failure happens and you need to be prepared. Where this ended up though, is that, everybody gets a game day. So, our journey with reliability here was, every team was doing these game days. Right? We throw a half-day session working through learning, understanding about how the system can fail and recover, validating dashboards, paging, all that good stuff. But it wasn't like scalable, right? And our approach here too was like, I don't know if anybody is a fan of, used to call me on my cell phone, but like we were trying to convince people, hey, you're getting paged at night. Like, look at this list of pages. We want you to sleep. We want you to like do your job during the day and not worry about the night. So like we were using like kind of like these metrics to show like how it can improve over time, right? And it was a good selling point. But at the end of the day, like your code, your project, that's your baby. And sometimes you get called in the middle of the night when something changes. But like, how are you going to catch that change, right? Is you're going to catch it once a month or once a year, right? Back again, right? DR testing once a year or more continuous testing like frequently. So like as like the approach here, so again, about 4 years, right, of working through all this. When I say 4 years, it seems like a long time, but it didn't feel that long. But right, we were trying to get into more of a self-service, right, an automated fashion, such that after X many changes in the environment, like holistically or like on an application, something would happen automatically, right? And when I left, that's where the team was heading, right? Again, making it through. But kind of where I wanted to have a stopping point is like, if anybody has questions, again, ask, but you don't need to do everything that I just talked about and take 4 years to build out like a chaos engineering or reliability program, right? Like what Corey said, game days are still good. Like definitely, right? It builds a community and culture and learning. It's it's an amazing opportunity to take like a new engineer on a team and like run them through all these like failure modes and like train them up and make them feel confident like when they're going to get paged the next week as their first on-call shift. But in order to catch like all this configuration that might drift between, you know, all these microservices, you have to like automate things, right? And that's where it's so important to look at your CI/CD pipeline, right? And kind of bake in these experiments that test the resilience mechanisms in your code or your infrastructure to validate that they're still functioning, right? And that's where like Netflix, you know, there's another meetup that we could talk about with that too, right? Like Netflix had scaled out like their chat platform, right, to do that continuous testing. But the story here too is like not everybody has to be a Netflix to be this, you know, reliable and resilient, right? Like we're like at Harness, we're trying to build that in automatically, right? So that you as a developer or a team can easily adopt these principles without having like the significant cost and effort of running it.
Yeah.
Were you gonna say something?
Yeah, getting it in that pipeline, it's critical. It's got to be easy so it doesn't feel like a whole other thing that teams have to do. And what I also love about some of the stuff we're doing next quarter is, you know, integrating with our service reliability module. So teams that are getting started, quite often I'll see, you know, a center of excellence or a core group of engineering and organizations really want to get started, and they'll pick one or two teams. But what I always ask people, as an engineer, are you going to listen to someone like me who's just loud and saying, hey, let's do chaos engineering? Or do you want to see quantitative, objective metrics that show how the early adopting teams have trended against their SLOs, their SLIs, and other key quality metrics? It's just critical. You know, one thing I'm also curious about your feedback is when we talk to different organizations, like quite often I'll see like, you know, maybe a software company where reliability matters, but, you know, they've also got some pretty crazy, you know, feature velocity, you know, requirements. I've seen them maybe do like, rather than 4 to 5 experiments in a game day, I've seen them do like weekly, like 1 experiment at a time or bi-weekly. I've seen that. And I've also seen some banks where they're worried game days might sound like they're having fun, like a pizza party. So they've rebranded successfully just like a hackathon or an enablement session. Have you seen anything like that on your side to kind of get buy-in and again, kind of sell in that this doesn't have to be a whole new thing?
Yeah, for sure. So like hackathons are super popular, especially like with companies that have innovation labs. If you've heard of that, where they can just test things quickly, rapid prototyping. So it's honestly like a great way to like start a hackathon, whether that's 1 day or a week, depending on the flexibility of what you have. And then like do a chaos experiment. And like Harness, for example, like Dave's group, they've helped people with hackathons in a way and leveraging, you know, like some of our open source CI/CD tooling, right? And then kind of working that out, which is great. But like another thing, just from my Target experience, is we partnered with like the digital performance team at Target, who was already doing like load and stress testing, right? To kind of validate that they could scale up the environment, like for a peak cyber Monday sale, right? So we found that group who was already doing this testing. And then we introduced the concept of chaos engineering to them to say like, hey, while we're doing peak load testing, let's introduce a network disruption, like a fault injection, like increased latency, just to see how the API calls handle that at load, you know, just so we can protect the user experience. So then that was an easy sell-in. And then since people were already doing load testing, because that was already a sold concept, then we coupled that together so it was baked in, right? So like those are 2 examples of, right, where you can kind of bake chaos engineering or fault injection into an existing process. So you don't have to go through too much of a sell. You can just kind of tell people what to do, especially if you make it easy.
Yeah, as long as they, especially if it's easy, and as long as they buy in and they understand why, you know, the standards are, and they can really own it, you know, it's really just key from what I've seen as well.
Yeah. Any questions that people are thinking through, or like where you're at in your journey and who you're working with, and any blocks that are happening that we could help navigate you through?
Yeah, it looks like Corey's still on too. So if he's listening in, if you have questions for him or Matt, on this topic, we're certainly happy to dive in. I don't think you want to hear from me on them though.
Yeah. Corey, anything going through your mind?
No, I think you nailed it. Again, I think that, ultimately companies like Harness, and again, us adopting these things into the underpinnings of everything that we do is like so critical to making this type of work successful. It's so hard to get real traction on this by yourself. And ultimately it really, like I said, earlier, it takes an entire organization, it takes a whole team to really buy into this to make it successful. Like I very rarely have seen individual teams be able to like push these types of initiatives by themselves. So I think again, companies like Harness and again, the tooling that's coming out of the CNCF and just the underpinnings of how this stuff is built into things like Istio and Service Mesh, et cetera, is we're all better off for it.
If it don't integrate, no one's gonna do it. Yeah, there's just so many requirements. There's so many other things to do. People balancing work life as well. It's just got to be easy, and that's really what we're aiming for here.
Yeah. Dave Nielsen asked a question. He said, when in the journey is a good time to try a game day? So you can try a game day anytime. Like some recommended spots in the journey. So like one of the sweet spots, like from my experience before, was working with a team that was about to bring their new service into production, right? So like a bad habit, right, is to do load testing like once you get into production and then like just see what happens, like have your customers do it, but you should practice it. So like we got in the habit of doing, production ready chaos engineering testing. And again, we leveraged game days there. And it worked well, but that couldn't scale at all, right? And we ran the same tests again and again with these teams for multiple game days. But basically, like if we could have automated it in a pipeline such that when a deployment happened, whether it was through a different deployment pattern or what have you, right? Like that would have been the zero effort, like integration, like Andrew said, such that we could have kind of, I don't like the word like governance, but like guidance is more fun, but we could have guided all the engineering teams to run a series of 5 reliability tests like with these chaos experiments, right? That if they pass it, then they would know that they're like a production ready app, right? So like the resilience mechanisms that we could test with different faults, they could be confident that it would weather an incident that happened, in a week or 2 weeks when they're in production at full scale, right? So we were trying to do that again with game days, and it worked like one team by one team. But again, you really need to have that automated just so developers don't have to think about manually doing that. They understand how it works, but if you can automate it, right, and make it zero effort, and then show them data, you got to have data, like as Andrew was saying before, after, then that's the powerful thing that can happen, right? That's really what will make it scale across.
Yeah, and really what I always say, especially getting started on this, quality over quantity. You've got to have the right people involved in these sessions. They can really thoughtfully map out the architecture, what failure injections they're going to run and why, what they expect to happen. If you try having one of these sessions and you just want to have the session, you don't include the right people, you're just not going to have the metrics and the learnings that are going to be able to justify moving forward. You'll notice a lot of companies, especially if the higher level is kind of 50-50, having a couple unproductive sessions where you take engineers out of rotation is going to be, the death of it. So just always quality over quantity.
Yeah, any questions from the field?
I have a question.
Future we'll have some more topics, on like Chaos 101 type stuff or more technical sessions too. So definitely drop ideas in for what you want. Michael, were you asking a question?
Yeah, I have a question just in general, I guess, for the panel. Like, we deal with a lot of folks that are in the process of migrating onto Kubernetes from either a monolith or they have like just containerized microservices. So like, what would be a good kind of gauntlet of experiments for them to run to test the underlying resiliency of Kubernetes clusters?
Yeah. Some of the things from my
Or
experience,
opinions on it? Just curious.
yeah, for sure. Some of the things that from my prior experience that we did with the platform engineering team was just understanding, as app teams were deploying their apps on our cluster sizes, that we were trying to figure out how big to scale and how to segregate like on namespaces, just so like apps wouldn't compete, was just consuming resources like CPU and memory, just to validate that Kubernetes was doing its thing by, like seeing that restarting, like moving the workload. But that gets like the resource, experiments are great to do that, just to understand that behavior, right? And it should work, but sometimes it doesn't, or the application doesn't handle that restart, and then the user experience is impacted. So those automated attacks work well, especially as you're like scaling. And then network attack, like network experience with latency, just to understand dependencies, like what's a critical dependency or not, especially like if you're migrating from like an on-prem data center, to the cloud. Like sometimes you just aren't aware of all your dependencies, like what's a critical one, what's less critical. So network attacks work well for that.
Cool.
I don't know if Corey or anybody else has any input on that, but for Michael, if you have any other questions or anything that you've tried in the past.
Yeah, what I've just traditionally seen when I talk to organizations that are starting with chaos engineering, quite often as a company, is a migration to a new tech stack of some kind. You don't have to live with yesterday's failures. There's obviously a reason why you're making that shift. Now is your chance to kind of build things right from the ground up.
Yeah. Another thing, I
Right.
mean, with the trends in GitOps and everything, right? You can leverage like harness chaos engineering, right? So like if your platform has a specific change, you can trigger different chaos experiments to run, just to validate if your system can still behave through that failure mode. So I don't know if you've tried that before, Mike, but that's another way to like automate and just kind of validate that your system, is still going to be like resilient through different performance patterns. Cool. Any other questions or even topics you'd want us to speak to next time, or anything to help you along your journey?
Yeah, we're really going to have a focus in Harness of really educating people on real world use cases, how you can make things better that you're already doing better or easier. And we're really going to have a focus on having people who've done it before on these types of podcasts and webinars, so you can really have the chance to ask questions and learn from some of their experiences. And again, a lot of the things we said around culture and the social aspects of this, it sounds like so common sense, but the amount of times that I sometimes see people not remember the human and kind of try to force this down teams' throats with all the other priorities, you get a bunch of silent smile and nods, yep, and it just never picks up traction, because sometimes people are afraid to fail, or they don't really see the value in the way that you're portraying it.
Yeah. But yeah, no, thanks for the feedback and the comments too. What's fun is, we talk about chaos engineering today, but like Harness and like this meetup, we talk about security testing, cloud cost management, service level objectives, continuous integration, continuous delivery, feature flags, which is another huge thing for the developer experience too. So glad y'all could make it. We can hang tight for any last minute questions or in the comments, but it's really great to see everybody here.